Hello, and welcome to 5 Minute Math. Today we are looking at the 2025 third grade STAAR test, and we are looking at lessons learned from this test and how we can improve our instruction. We are specifically looking at any readiness standards in which statewide we tested under 60% proficiency, and we're going to start with our lowest readiness standard first, 3.4K, move all the way up to 3.5E. So let's look at 3.4K. We are solving one and two step problems involving multiplication and division. And there were two items on this test. And as you can see, neither of them did really well. On number 10, we had 21% of our students get this correct. First, what we needed to do is we needed to take our total, 60 blocks. So let's take our total, 60, and we're going to split it up between Amy, Carl, and Liz. So this is step one. We're going to take our total 60, and we're going to split it up into three equal groups. And let's call this Amy, Carl, and Liz. Now, if we want to think of step two, we can think of Amy. So now we're just dealing with Amy right here. Divides her share into four equal piles. All right, and so we can cut this third into four equal piles. Now, what does that mean for us? That means that we need to take our 60, we need to divide that by 3 first. That's going to get 20. Amy's got 20, and then we're going to divide that by 4, because we want to find out how much is in each of Amy's piles. It's 5. Only 21% of our students were able to get that correct. We ended up having to divide twice, something that they don't do as often as add and then subtract, or multiply twice, or multiply then divide, or subtracting twice and dividing twice are two-step problems that we don't use as often. This one, we've got Frank, that's 90 pictures, and he needs to put them into 6 pictures on each page, right? So this is equal groups, which means we're dealing with multiplication or division, and there's no A, B, C, or D to choose from. We just have to type in our answer. So that makes it more rigorous to begin with. So this is actually 90 divided by 6. And if our students know long division, that's great. If not, there are a few different ways we can do this. One thing I would recommend would be maybe using the area model that we're familiar with. But what I want to do is I want to put this 90 on the inside because we know that 6 goes into 90 blank times. And then what we could do is we can kind of split that 90 into maybe 60 and 30. We're looking for numbers that are easy to divide with. And 6 goes into 60 10 times, 6 goes into 30 5 times. You add those two together and you get 15, and that is our answer. And as you can see, only 35% of our students were able to get that one correct. So one thing that made number 10 difficult was that the first step gave us an answer of 20. That even wasn't an answer choice that was available. You'll notice that 20 was not available, and so that might have thrown some people off. 55% of our students chose A. And so if they weren't capturing this on the number 10, there was a two-step problem. What they're going to do is they're going to see the word divide. They're going to see two numbers, 60 and 4, and they're just going to do 60 divided by 4. And that's 15, and that's 55% of our students didn't necessarily recognize this as a two-step problem. They just saw the word divide, saw two numbers. 4 goes into 60 evenly, and they figured that's it. So we had to divide twice, which was the challenge. And that number 21, that second one, we could use long division if they know it. I use an area model, or we could just do repeated subtraction, right? So our students know that if we take our 90 and we could just subtract 6. Now it's a lot of subtraction, but we could do it all the way down, and we can see how many times it takes, and it would end up taking 15 times. So that could also work. So we need to give our students strategies. So what does that mean? Whenever we see this white text on the screen, those are instructional implications. First, you notice that I immediately started making sense of my first problem by drawing a strip diagram. That's going to be our biggest tool that we can use with our students, help them make sense of the problem by drawing the strip diagram, because if they did that, they would have noticed it was a two-step problem. And then we could use an area model to solve larger division problems. We're not really getting into long division until fourth grade, so we don't need to worry about that algorithm yet. They can use an area model. They can use repeated subtraction. There's lots of different ways students could be successful on those two, but that is our lowest readiness standard, 3.4K. Next, we have 3.5A, and this is representing a 1 and 2 step problems with addition and subtraction. So we've got this particular item, and we only had 38% of our students get this one correct. Now, this one is a little bit difficult here because we don't see many number line problems. We should start practicing those if we're not already doing so. So a library has 530 books at the start of the day. Where's 530? 530 is right there, which means I'm thinking I should start with this ray because that's got a starting point, and then it goes to the left. So what does that mean? And it ends with 280. So that's going to be subtracting something. So 530 minus something is going to get me 280. Well, I can use just a fact family to do that missing number, and I can figure out that this is going to be 250. All right, you notice everything says 250. Now, when we get that 250, I'm at that 280, and then I go to the right. So if I'm going to the right, that means I'm going to be adding something. And I end up at, what's that, 430. So 280 plus something is going to get me 430. Let's subtract again to figure out what that is. 430 minus 280. That's going to be 150. All right, so what I ended up doing was I added 150 after I subtracted 250. So we had to use this representation to kind of interpret what's going on. Then, if we do all of that work, now I've got to map that to either the word borrow or return. So if we don't have familiarity with what happens in a library, that's going to be difficult. So when we return something, that is a minus. And so we're going to subtract here. And actually, when we return something, that is a plus. Excuse me for that. When we borrow something, we're taking it away from the total. And so we're looking for this order. Everything is 250 and 150. But I'm looking for a subtract first, and then a borrow or a plus second. So our answer here is B. Only 38% of our students got this correct. This was definitely a challenge, not only for interpreting the number line, but then putting it into the context of borrowing and returning. Because it takes context to understand we're looking for the number of books that the library has. Because if I am returning, that means I am losing the library book. So I am subtracting the library book from me, but we're doing it from the point of view of the library. So returning to the library means you're adding to the library. That's where it gets confusing. So we had interpret, borrow, and return. And we had to find 250 and 150, which are nowhere on this marked off. Like 250 is right there, and 150 would be over here. So we had to first figure out that 250 and 150 are the lengths of the bars, not the starting and stopping locations. We had to start with the ray at 530 that moved to the left. And then we had 30% of our students choose A. So they just inverted that. So you had the feeling that they kind of knew what was happening, but instead of returning meaning adding, they inverted it to mean, uh, or returning meaning adding. They wanted to do that first, and borrowing, they wanted to do that second. So the words got switched, which means they ended up inverting the order of the operations. And so one thing we can do here in our instructional implications is instead of immediately rushing to calculate, let's just look at some problem situations and have students interpret the implied operations, right? And this is where generative AI might be very helpful. Of write some word problems and come up with a whole bunch of different contexts that imply addition, subtraction, multiplication, and division. And just see if students can start reading those and start understanding what operations are involved without necessarily representing it, without necessarily solving it. We definitely have to practice with number lines because that's not as common as some of our other models that we might use. And instead of calculating, look at our answers, right? The verb in this standard says represent, it doesn't say solve. So all of our answers are in words. And so they might be looking for a number. Instead, they've got four different statements that they need to read and interpret. So that's what's going to be a challenge for these students is have them describe the actions to better mirror the answer selections. Use words, talk to their neighbor, talk to their partner about what is going on rather than always looking for simply the answer. Next, we've got 3.5b. We are representing and solving one and two-step multiplication division problems. Are we noticing a pattern here? If we look at our lowest, we're solving one and two-step problems. Then we're representing one and two-step problems. Now we're representing and solving one and two-step problems. So multiple step problems, whether we're solving it, whether we're representing it, that's our biggest area of opportunity in third grade here. In this case, we're looking at multiplication and division, and we've only got one problem here, but we had 38% correct. So let's take a look at what's going on. And I am going to draw a strip diagram. Strip diagram is called out, so they need to be comfortable with equations, strip diagrams, and arrays here. So 12 students in class. So I'm going to just make my total. And this is key. The students see that this is the total. All right. Half the students played an instrument. So I'm just going to take this and I'm going to cut it in half. All right. So here's my instrument. And then I'm assuming this is no instrument on the other half. Now, there are an equal number of students who play the guitar, the piano, the violin. There's three of them. Now, what I need to know is that these three are instruments. So piano, guitar, violin equal the instrument, and that's going to be a vocabulary challenge for some of our students. Now, I'm looking for how many students played the guitar. Well, there's of this half, I need to cut it into three equal parts. Here's my guitar, there's my piano, there's my violin. And so I could look at what I did. I took my 12 and I cut it in half, which means divide by 2. There's 6 of them. Then I took my 6 and I cut it into 3 equal parts because there's an equal number of students who played the guitar, the piano, and the violin, and that equals 2. Now, they don't give us the 2, they give us the question mark, but that's fine. And so we see that we've got our answer here as D, and only 38% of our students got that right. Once again, we are dividing twice, something that they are previously have not been familiar with, but we've had to do it twice so far on this test. So we need students to first understand that half means to divide by 2. We will get into multiplying by 1/2 and understanding that those are reciprocal operations, but that is a 6th grade standard. So first off, half needs to be mapped to the operation of division, specifically dividing by 2. And then on its own, equal number could mean either way, multiply or divide. So we have to put those in context to understand what's going on. We had to divide twice and then represent with equations, which made it a little bit more difficult, especially if they're used to drawing a strip diagram on everything. And so I used a strip diagram to organize my thinking, but I then had to transfer it into an equation. So we need to make sure our students are doing both. So once again, I suggest instructional implications. Always start with a strip diagram, helps represent the scenario. Now, we could have eliminated two answer choices by finding the question mark and asking if they'd answer the question of how many students played the guitar. Before I do any calculation, we're looking for how many students play the guitar. How many total students are there? 12. All right, so I know it can't be more than 12. But look, look at what A gives me. 24 times 3. Okay, that's 72. So I'm going to get rid of that one. 24 divided by 3. Maybe. That's less than 12. 6 times 3. 18. More than 12. And then 6 divided by 3, there's my 2. I could have eliminated A and C if I just went ahead and figured out what that question mark was on that second operation, and then made sure I remembered, hey, I've only got 12 students in the class, so we could use some logic and reasoning to help out as well. Next, 3.4a, and look what we're solving. 1 and 2 step problems. So our 4 lowest readiness standards are solving and representing 1 and 2 step problems with all 4 operations. We get 2 different problems here. We didn't do too bad on number 6. So we've got a table. We got how many more hours does Tina hike in summer and winter combined? Okay, so summer and winter, 360, 344. We combine them. We're going to get 704. Then in fall, so 704 minus, what's my fall? 610. All right, so we've got 94. We had 52% of our students get that correct. You'd like to see that at 60 or above, but that's not horrible. That's a well-written problem. We did a little bit worse on number 16, and as you can tell, there's no A, B, C, or D to choose from. That always makes it more rigorous. So we've got 2 bags. One bag contained 250. All right, so I'm going to do this right here. There's my 250. Another bag contained 400. These are not proportional. I'll just put 400 right here. Casey used all but 36 of the total number of beads for an art project. So what is the total number of beads? All right, so we've got 2 different bags here, 250 and 400. And then we used all but 36. Okay, so I've got my total here, or I can at least find my total easily, right? 650. And that's as much as I'm going to get because there's only 2 bags. I used all but 36, so I'm going to use all of one bag and most of the other. Here's my art project. Really what I'm doing is I'm comparing these two. And then I know that I've got this 36 bead gap here. So I need to take my 650 and I need to take away the 36 I didn't use, and that's going to give me the total number of beads used. And so let's go ahead and subtract that. That's going to be 614, and we only had 39% of our students able to get this correct. So we have to do the same thing in both different problems, which is very typical. Sometimes you will subtract twice, but most of the time you're going to add and then subtract. So we should be very comfortable with this. Now for number 6, where there was multiple choice options available, 30% of our students chose A, which is simply this first step right here. So we've got some students, they were able to at least get started, and then they saw that answer and they said, ooh, 704, that's an answer. And they weren't able to realize that they needed to do something else. And so that's always going to be, not always, because we didn't see it on that previous problem, but most of the time it's going to be one of the answer choices is the answer to the first step only. And obviously number 16 was a little bit more rigorous simply because it had no choice options. It was just an equation editor. So what should we be doing? Well, if you haven't listened the first few times, I'll say it again. Let's draw strip diagrams to represent the relationships between the quantities. That lets us know whether we're combining, whether we are comparing, whether we have equal groups. Strip diagrams are very, very useful for students. And then if we need to keep each step separate or distinct, we can write each equation separately. So that's what I did here, is I did my first equation here, and I did my second equation here. And I did this first equation kind of in my head, 650, but then I did the second equation right here. And sometimes we'll have to, in upper grades, we will need to solve for something, and we might say that this missing amount, this fall, might be a question mark, and we have to combine it, right? So we might do like 360 plus 344 minus 610. And we can combine it into one equation, but we even saw on a previous one they had 2 different equations. So if we want to help our students see that there are 2 different steps, we don't necessarily have to immediately go straight to a single equation. Instead, we can keep the 2 equations distinct, knowing they can be combined if needed, but that might help us remember that we have 2 separate steps. Next, 3.7b, we're finally finished with the solving and representing 1 and 2 step problems. Now we're dealing with perimeter. And we've got 47% of our students that got this correct. So we have a rectangular birthday card. If you see the word rectangular birthday card, let's immediately draw the rectangle, width of 9, or length of 9, and a width of 6. What is the perimeter? Well, if we know what perimeter is, that should be fairly easy. If the top is 9, the bottom is 9, the left is 6, the right is 6, and then we just need to add those. That's 15, that's 15, so 15 plus 15 equals 30. And so that is our answer, but only 47% of our students were able to get that correct. Now, in third grade, there is no formula provided on the reference chart, so students need to understand what perimeter is. It is the first time that they are exposed to perimeter, right? That's new to third grade. And so if they didn't recognize it, there's no formula for them to use because we don't get into formulas until we get into fourth grade. Now, 24% chose A, and 24% chose B. So let's look at what we have here. And you should see that you can get these easily. This is 9 plus 6. This is 9 times 6. So that makes sense. And if you get the 48 that those two combine with the 47 right there, you have like 95% of your students did something constructive with 9 and 6, right? And so that makes sense. So this comes back to vocabulary. We need to make sure we understand what perimeter is, our students know what to do with it, and just draw a picture and add up all four sides. And if they're only given two sides, they need to know as a rectangle, it is a parallelogram, which means the opposite sides are congruent, and they can fill in the missing sides with the information given. We've got 3.3F next. We had 50% of our students get this right. We are representing equivalent fractions, and in third grade, our denominators are limited to 2, 3, 4, 6, and 8. So there's a limited number of equivalent fractions that we can have. So 4, 6 is one of them, and 4, 6 can only equal, in this case, 2/3. Now, how do we get 2/3 from here? Well, it's always going to be represent. We're not necessarily using the algorithm. We are not multiplying the numerator and denominator by the same number that comes in fourth grade. In third grade, we're always representing. So there's two ways we can do it. We can take a fraction like this and we can cut it in half. And we can say, all right, so now I've got sixths. I took each third, cut it in half, and I've got sixths. And look what I've got here. I've got 4/6. So therefore, this 2/3 equals. If you cut the rest of these in half, you're not going to get that. We also could have eliminated this. This is 3/6. So if it's, I mean, the denominator is fine, but obviously 3/6 does not equal 4/6. This is 4/8. So we might have been able to group these. The other option that we teach them to do is if your denominator is even, which other than thirds, they're always going to be even in third grade, group them in pairs. And what do we get here? We get that 4/8 is equal to 1, 2 out of 4. And it's still an even denominator, so we can even go a little bit bigger. We can put two pairs together. And we can see this is equal to 1/2. So that's how we can generate equivalent fractions by simplifying. And this is going to be 4/4, and that's not even, that's equal to a whole. So that's not going to equal to 4/6. The numerator is the same, but the denominator doesn't work. And so 24% chose B, and it's probably because they didn't really know how to attack this problem, and it's the only one that at least had the correct denominator. They know the numerator was wrong, but at least the denominator was something. But that's a lot of students to choose that, even though it's very clearly not 4/6. So we need to help our students generate equivalent fractions by cutting in half like I did. So you can always take a fraction, no matter what that fraction is, right? If we do it like this, you can always generate equivalent fractions by cutting in half. And then if you want, you can cut each half in half. And you could just keep going on and on and on. Or you can group in pairs. So let's say we've got 6/8. So let me draw eighths here. And if our students see 6/8, how can they equate that with 3/4? Well, we need to recognize that we have a denominator that is even, which means they can be divided by 2, which means I can put these in pairs. So let's put these in pairs. 1, 2, 3, 4. So 3/4 is equal to what I originally had, 6/8. And that's the way we can visually, because it's always going to be with representations. And we could do the same thing with these fraction strips. We can use those with number lines as well. 3.6c, we are looking at 50% overall mastery of this area. So area and perimeter were both areas of growth here. And we need to find the area of the shaded rectangle. And so there's a few different ways we can do this. If our students have started internalizing what the area formula is, we can say I've got 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 times 9 equals 36. Or if it helps them, they can start drawing this. Now, unless they can draw straight on the screen, I wouldn't want them to try to recopy this on their paper because there's a good chance that they might miss something. But if we see that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, I could just skip count by 9. 9, 18, 27, 36. Either way, our answer there is 36. Now, 21% of our students chose B and 18% chose A. So let's look at those two. 21 and 18. If students don't know what to do, what are some unique things they might do? Well, 50 is actually the number of grid lines. If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grid lines here. 1, 2, 3, 4, and I missed one. 5. Right there. 10 times 5 makes 50. Or this is 30 is actually the unshaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So another 11 down here gets you 22. 23, 24, 25, 26, 27, 28, 29, 30. So they did a lot of work and they just chose the unshaded. And so we need to once again help our students understand that area, which is going to be so important moving forward. It's not just a one-time thing, obviously. Area is the amount of space inside a two-dimensional object. And so that's something we cannot stress enough. And if they want to, they can draw grid lines like I did. And it wouldn't have hurt for them to start internalizing that emerging area formula. We don't need to count all the squares if we know the length times the width, because that's a shortcut, because that's what we do with arrays. We've got 57.5% overall mastery with 3.5e. This is our final one. We're representing real-world relationships with number pairs. And so we've got a table here, and we need to drop down our answers here. We need to figure out what's going on between the number of months and the books read. And our answer here is going to be in a sentence because it says represent in a table, which is what we did right here, or verbal description, which is what we're doing right here. So that's how we need to practice this, by taking a verbal description, putting into a table, by taking a table, putting into a verbal description. And so we've got 2 going to 10, 4 going to 20, 6 going to 30. So I can do 2 plus 8, or I can do 2 times 5. So those are my two options, plus 8 times 5. And let's see which of these works. 4 plus 8 does not give me 20, but 4 times 5 does. And so I can verify that 6 times 5 also works. So our answer here, we don't see our choices, but it's going to be add, subtract, times, and divide, and then different numbers here. We're going to times 5. Now, 51% of our students got full credit. 26% of our students got partial credit. So if we take half of this and stick it onto here, so that's about 64% correct. So this one was actually a little bit easier than this one. On number 17, we only have 51% of our students get this correct, because we have the number of classes that Miss Elisha teaches is equal to, so I'm going to say classes equals, you see that equal, the number of days times 6. So I need to find something that says classes equal days times 6, but notice how these are inverted. The days goes on the left on all of these. So they gave it to us kind of backwards. So what we would need to be able to do is we would need to be able to take this and then flip it if we wanted to use this. We would need to know that on an equal sign, you can flip what's on either side. You can say days times 6 equals classes. Now it matches our tables, and now we're looking for times 6. So does days times 6? No. No, that's a plus 6. This worked. And no, that's a minus 6. Okay. So our answer here is going to be C, but you notice we had to flip because they gave it classes first and days second. That didn't match the order that we saw in the tables. And so we had a good amount of students receive full credit on the first one. So that's pretty good. 31% on our second problem, number 17, though, chose A. And you see here that instead of this being a times 6, this is actually a divided by 6. So let's get rid of this. This is actually divide by 6, divide by 6, divide by 6. And most likely what happened here is that they didn't flip those, and they were looking from right to left, because 5 times 6 makes 30, 3 times 6 makes 18, 1 times 6 makes 6, but they weren't keeping up with the classes. Should have been on the other side. So we need to help our students get that oriented correctly so we can match up the classes with the classes. And so we need to practice describing the relationship in both in words and applying that description to a table. And then the directionality on both of these is left to right, right? So we're going like this. But every once in a while, you'll see a table like this, and they need to be able to go up and down. So they need to practice that directionality in both ways.